the online course, Practical HPC. Credit where it's due. We present this in collaboration with PRACE and the EPCC. They are the people responsible for the supercomputing MOOC that provides all the background information on high performance computing, which you'll need to understand the CHPC's supercomputer.
Kevin, you stop sharing?
Today is the welcome and an overview of the course, as well as a
Kevin,
on a
Kevin,
yeah?
you stop sharing. You stop sharing your screen.
Oh, did I? Wow. Let me fix that. Is that visible?
Yes, I can see it.
Okay. Still visible?
Yes.
Made it full screen. Okay. Great. So just to say that today's an overview of the course specifically. We'll cover all the aspects of course, how it's going to run, all the various platforms that we'll be using for this online course, as well as some of the details of how particular things will work. So starting off, what is this course going to cover? And I'll mention some things it won't cover later on. But the idea is that it's a practical introduction to high performance computing for users of the CHPC specifically, or users of other similar HPC clusters. All right. So it's preceded by the supercomputing MOOC. And the first 3 weeks of that MOOC, which we've labeled SE1, 2, 3, and 4 here, are essential for giving you the background information and the concepts that you will need to understand this course. So that'll be the foundation needed for this course. Week 1 of the MOOC covers supercomputers. Basically, it's an introduction to high performance computing. So that's the one you should have completed by now, or if you haven't, as soon as we finish this session today, go and start going through it. Then the second week is about parallel computers. In other words, the hardware that goes into building a parallel computer. Okay, so that's the second week that you should complete before Thursday to make sure that you can understand what we're talking about when we start showing you the CHPC's cluster, the hardware about that. Then the third week, which is the last week you really need for this course, is parallel computing. And that explains how supercomputers are programmed. So that's an introduction to parallel programming. Just the basic concepts. In other words, how software uses that parallel hardware that is described in week 2. Week 4 and 5 are optional. Week 4 I'm mentioning here as maybe of interest to give you some additional information and background for later on, but that's computer simulations, and that describes how various HPC applications take advantage of the parallel hardware and how they work. But like I said, work on and complete week 1, hopefully by tomorrow afternoon session. Complete week 2 before Thursday's session, and complete week 3 before next Monday's session. All right. Weeks 4 and 5 are optional. You may find week 4 on simulations helpful when understanding how HPC applications work. So the topics in this course: the CHPC hardware and systems. So all our examples, all our demos are going to be on our cluster. So we're going to talk about our systems. We're going to describe how to use our systems. The CHPC has a very conventional supercomputer cluster. So the stuff you'll learn here, the practical techniques, etc., will transfer to most other clusters. We'll, of course, point out the various differences. The next topic, and this is where we actually assume that you have the basic information about the Linux command line, but we'll sort of elaborate on that and talk about the Linux environment. Sorry, please mute yourself. Please mute yourself. Thank you. So you should be familiar with the basic Linux commands. And as I mentioned later on, where we use quizzes to actually check your knowledge, there will be a specific quiz on the basic Linux commands. We'll describe in more detail the Linux environment, specifically how you manipulate the environment with modules, what the environment looks like on our cluster and a typical cluster, and how to use that environment to set things up so that your job script, which is of course the whole aim of this course, can run effectively. So then the third topic, of course, will be job scripts and the PBS Pro scheduler. So we'll describe the scheduler, how it works, what is the user's view of it, and then how to write job scripts. We'll spend quite a bit of time on various aspects of job scripts. And that's because of the main topic of this week especially, which was how to convert your workflow to a job script. So before we can get to that part where we talk about turning an HPC application workflow into a job script, you need to really know what job scripts can do. So we're going to show you quite a few examples. We're going to get you to work in the pracs to actually set things up, run some job scripts, test out a few things. And that leads me to the how to fix errors. So one thing I like to actually show in job scripts is how to actually get diagnostic information in your job script. So if something goes wrong with your job script, you can go back and have a look at the output files and see what the messages are to see, for example, things like, am I in the correct working directory? Have I loaded the correct environment modules? And so on and so on. So we'll cover that. As I said, this is going to be very much a practical course. Then later on, we'll show some examples of applications, how you take an application's workflow, turn it into job script, whether it be pre-processing, a main simulation, post-processing, and so on. We'll show you a few examples. Then the second week, and this will run into the second week probably, so we'll probably still be working on this on next Monday. But after that, we'll start looking at scaling and performance. So first of all, it's how to effectively use the cluster. And then the second topic is how to efficiently use the cluster. So we talk about scaling. In other words, how many nodes, how many cores do you request to get optimal performance from your application and the size of your data set or job? Okay, that'll take up a bit of time. And last but not least, certainly, we will also talk about installing your own software. I have some C and Fortran examples, but we'll also mention Pi and perhaps R if there's enough interest in it. Okay, so those are the topics. And as I said, it's very much focused on the practical side of things, which leads me to how we are arranging this course. So this is the schedule. It's 2 weeks of supervised learning starting today, ending on the 5th of September, right? So every Monday at 2 p.m., Tuesday, Thursday, and Friday during this period, we'll have an interactive session, 60 to 90 minutes. I mean, we'll only run into 90 minutes if there's lots of questions, for example. And the typical structure of those sessions will be a 15-minute lecture or demo, followed by a 45-minute practical. We'll give you a lecture note or tutorial to follow or a worksheet. These are not compulsory, but they are the best place to ask questions and to actually see things being done. Right. Last but not least, we have the assignment deadline, which is the 9th of September. So this is after the supervised learning period has ended on the 5th of September. You'll have a few extra days to complete the assignments. And that leads me to the evaluation. We have quizzes which check that you have understood the information in the first 3 weeks of the supercomputing MOOC. So there'll be 3 quizzes for that. There'll also be topic quizzes. The first topic quiz will be about the Linux command line. Other topic quizzes will be about the topics covered inside the course, like the CHPC cluster and so on. There will be practical assignments, right? First practical assignment will be you writing and submitting your own job script. So they're pretty straightforward. Another practical assignment, which will be a little bit more demanding because it'll involve you doing some work on testing scaling. We'll give you the application, so you don't have to worry about which application. And then answering some questions about it. In other words, demonstrating that you actually understood what is going on with scaling and performance. And lastly, if you would like a certificate of attendance, you can request one. It'll be a digital certificate, a PDF file, if you've completed all of the above evaluation. In other words, the quizzes and the assignments. All right. Okay, let me introduce us. I'm the convener of the course. All right. My background is in applied and computational mathematics, and I mostly look after scientific computing. Then we have Benjamin, software development and scientific computing. Ines, bioinformatics and computer science. And Mteto, weather and climate, earth and space sciences. You'll get a chance to speak to all of us and each of us in the interactive sessions, of course. At the stage, I'm going to stop sharing and hand over to Benjamin, who will just talk about the various platforms we're going to be using for this course. Thank you.
Great. Thanks for that, Kevin. So yeah, so you might have seen that we were communicating with various platforms. So I'll just give you a brief overview of what we're using. So primarily, it was obviously you registered on Indico, and then we had you all received your notification to communicate via Slack. So Slack is going to be our main communication, resource at the moment. So I'm just going to share the screen just to show you what a current Slack environment looks like. So most of you, it seems, have already joined Slack, and I just want to show you the general channel where most of the announcements will be. So I put up here, this will be the main place where you'll see the Zoom link that you need to join. So I say, this is the opening session, and I put the Zoom link over here. And importantly, where the content will be located for the course, it will be using Moodle. So you should have received your all your login details for Moodle. If you haven't, you can chat to us, and I'll speak about the different channels later. But Moodle will be an environment where we will show you the content for the course. Importantly, we have various Slack channels. So again, the general channel is for announcements. I asked everyone just to do an introduction in the introductions channel. If you have any Moodle-related questions or comments, use the Moodle channel. And then also, we have a random channel just to post any questions or queries that you want. And just to reiterate that we have 4 interactive Zoom sessions. So Zoom is our other medium that we will be communicating with you online. So obviously we have Slack, Moodle, and now Zoom. So Zoom where all the interactive sessions will happen and along those lines. Kevin, do you want me to show them Moodle, or do you want to show them Moodle?
Sorry, you go ahead and show them Moodle.
Okay, cool. All right.
I'll make comments as
sure.
needed.
Let me just new share. Let me just open my Moodle quickly. And while I'm just
I'll just sorry. You wanted to say something?
Yeah. So while I'm just opening up Moodle, just in the Zoom chat, just let us know where you're zooming in from. It's always useful to know. So in the Zoom chat, just say the city or country even that you're zooming in from. And then while I just open up this up here, just give me a moment. Switch role
Yes.
to.
So I just want to mention about Moodle. This is where you'll find all the contents of the lectures, etc., the course content. And the structure is intended to allow you to sort of study by yourself. Okay.
All right, so this is the Moodle environment for the winter school. So currently we have, this is what the first three, sections are just describing any notices, important privacy notice. So very importantly, you must check this to kind of proceed with the rest of the course. This is for Puppy. And then just a notice about Zoom and Slack workspace. So you can go through that. And then these are just a few introductory slides, which you will can go through, and I will briefly show you some content within the slides just regarding the CHPC. But generally, this is your Moodle environment. Some of you have joined our summer school before, so you're probably familiar with this. This is your dashboard where you'll be accessing most of your content. If you go to your calendar, you'll see the Zoom sessions that'll be happening. And then this is primarily the only place you really will need to go to for your Moodle environment. You can chat to other people and the staff if you want to in here, but use Slack rather as your main resource for that. Yeah, so again, once the content becomes available, you'll see more content, showing up for these weeks over here. Kevin, is there anything else you want to mention?
Is there nothing showing up for today? It should have opened up already.
Nothing seems to be open just yet, but these slides obviously quite important to go through.
Yes.
Just
sorry, I know what it is. It's because I need to enable the first quiz. That's right. Okay. I'll do that later on this afternoon after the session. So once you've enabled the first quiz, you should be able to see the first section.
Okay. All right, so I'm going to stop sharing. Kevin, or do you want me to carry on with the CHPC overview?
Yeah, please carry on with the overview.
Okay. And I see in the Zoom chat, there's a few queries about not being able to log into Moodle. So please just message us on Slack. We can help you there.
I could just explain that quickly, because I did drop a message into Slack. Maybe I should actually move it into the Linux channel. So I should just explain that you have a unique username on Moodle, and you should have received an email with your username and password. All right, please check your spam folder if you didn't see it, and please whitelist all messages coming from @chpc.ac.za. All right, so you'll use that username and password to log into Moodle. If you find that the password doesn't work, or you didn't receive that email, ask me and I'll give you your username, and then you can do a password reset using that username. Don't try do a password reset using your email address on Moodle, please. First ask me for your username if you can't find the email from the system at all. So that's just something to keep in mind, is that we use separate and unique username logins for Moodle. Okay, thanks.
All right, so I'm just going to share my screen. So this is some of the content that is available already. Just full screen. I'm sharing my screen over here. So everybody can see this, hopefully. So this is just an introduction to CHPC. So CHPC is a national HPC facility funded by the SA government. It's a Department of CSI, Science and Innovation, DSI, and it forms another under NICIS, or the National Integrated Cyber Infrastructure System, and administered by the CSR. It started its operations in June 2007 and is based in Cape Town. Currently hosts the largest HPC system in Africa, which is technically not true because one was just started in Morocco, so I think they are the fastest one in Africa. The CHPC has approximately 30 employees, and we have 3 divisions, namely research, technical, and operational. So we are located in Cape Town in Rosebank. This is a picture of the building where we're located. And again, I mentioned that CHPC falls under NICIS. So there are other divisions of NICIS, which is SANRIN, focuses on networking services, and ERISA are data services. I won't go into too much detail about the other divisions of NICIS. I want to focus on the CHPC. So the first cluster that was procured, I think, was in 2007, and that had 2.5 teraflops as far as I can. Yeah, well, it's as I said there. And if you've done the MOOC that you're supposed to do for this course, you should know what a flop refers to. But this was the first one that was used at the CHPC. Kevin, please comment if I make any blunders. I won't go through any ones further we have here. So Sun Constellation Cluster, 27 teraflops, and 2010 was 16. So this was a GPU cluster. I think this was a different cluster that was provisioned. And then also the Saber cluster, which was 61.6 teraflops. And then currently at the CHPC, we have the Lengao CPU cluster. So this was started in 7th March 2017. And this was the first petascale system in Africa. So just over 1 petascale, 1029 teraflops, or 1.029 petaflops. And this was ranked 2016, 121 in the world for the top 500 HPC systems, and 127 in 2017. I think we currently passed the 500 mark as far as I checked last. So Lengao is at the Swana word for cheetah, and the emphasis is on speed and being fastest. And again, it was the fastest HPC cluster, just over 1 petaflop. These are some metrics for the clusters, so you can go through this on your own if you're interested. Again, these terminologies you should be now familiar with regarding InfiniBand, parallel storage. LINPACK was also mentioned in the MOOC that you're supposed to do in preparation for this course. And yeah, I won't go into much more detail. So the current resources we have. So we have a GPU cluster since September 2018. And demand from users for that was primarily for liquid dynamics and machine learning as well. So just as a, yeah, so I think just want to mention that. And then again, this was, these next few slides to show the top 500 HPC systems. So we are not here anymore, but hopefully we will be, when we get a new system. So I won't go through much of these. All right, so in terms of the mandate for the CHPC, it's a research enabler role by the HPC. So we provision computational resources to South African academic research community for free. We have African SK partners, and also in industry, private sectors as well use our resources as well. We research enable role for CHPC's fourfold to access HPC hardware infrastructure, code and software support, research domain area support, and training education as well. So HCD, which is what you're part of all now for winter school, is part of HCD or human capital development. So we have dedicated domain specific scientists and engineers focusing on chemistry, material science, computational mechanics, physics, bioinformatics, astronomy, applied math, computer science, and many more. We have a technical support team, and we have an advanced computer engineering lab or SLab, and we also have trainers as well. So total users as of December 2019 was just short of 2,000, just under 500 research programs, and active users is just over 500, and active research programs just under 200. Yeah, so I won't go over this much detail. It just shows you total active research programs and core hours. So these slides will all be available, just of interest. So total active programs, so the majority is South African academic institutes, public sector, SKA, and SA industry are a small portion of that. And you can see the number of hours used as well is dominated by the academic institutes. Active programs, so material science, chemistry, computational mechanics, and bioinformatics. These take up the majority of the total active programs. And I guess science as well is a significant aspect of total hours used as well. So we have various programs, but these ones are the main ones. Yeah, so that is just a bit of overview of the CHPC. I'll probably go in a bit more depth maybe with the research programs the next few days. But are there any questions or comments? Kevin, do you have anything to further add that I might have missed?
No, thanks. I think that especially when we start looking at some application examples, we'll start talking a bit more about particular areas. And this is also where we are looking for feedback, because when we start talking about workflow to JavaScript, this is where we would like you and encourage you all to start asking us about your work, what you need to do on the cluster. And this is why we'll ask you to do short presentations on various things later on in the week about what you'd like to do and what you are all currently doing on the cluster. Also, when we do some of the practical exercises, we'll also call on you to explain what worked and what didn't work, for example. The intention of these practical sessions is to be very interactive as far as possible, to help you figure out how to use our cluster. Okay, thanks.
Cool. So I'm going to stop sharing now, and I'm also going to start a poll just to get some feedback from everyone. So while we continuing with our opening session, please complete the poll. I just started it now. I'm going to stop sharing, and over to you, Kevin.
Okay, thanks. I just want to quickly share what you can see on Moodle. This should be the student's view of this week. So this is today's topic. The way that it's set up is that each week is actually a separate page. So you just need to click on the week title to get to it. So if you have a look at this week, 22 to 28 August, there are 3 sections that, under which we've grouped the topics. The first one is the cluster environment at the CHPC. All right, so this is going to be all about the environment, the shell, Linux, what you can see on the cluster, how you can examine it, move around, etc. So heavily based around Linux command line, of course. Then the next section, section 4, will be the scheduler and job scripts. Well, scheduler and interactive jobs to start off with. And then section 5 will be about job scripts. Section 5 will probably be the longest section here. And as I said, it'll probably run over until next Monday. Okay. So today's topic is really just about connecting to the CHPC. There's a video and there's some notes. You can download the notes, have a look at them. You can watch the video, get an idea of connecting. I'll later on just show you a quick short demo of how I connect to it from a Linux system and what I actually see when I do connect. Okay, thanks. Anything else on your side, Benjamin?
No, you can go ahead.
Okay, I think I'm going to have to put up an FAQ on Moodle. Actually, if you can't log into Moodle, you can't see it. Okay, I'll put up an FAQ and pin it in the Slack channel about connecting to Moodle and resetting your password. Because I do see some messages in the chat from people who don't have any login. And then last point about logins is anybody who is not currently a CHPC user. And obviously, in order to work on the various practical exercises, you will need an account on our cluster. Please contact me after you have looked at the video about accessing the CHPC from our research scientist, Dr. Werner Janse van Rensburg, because that'll explain the procedure of how you go to our user portal and sign up as a user. So once you've done that, you can then contact me by emailing me directly, and I'll put my email address on in the Slack, and I will then add you to the Winter School program, and that'll generate and create a cluster account for you. So that's for anybody who isn't already a CHPC user. I think the majority of you are already CHPC users because that is the main audience. But for those of you who have not yet a CHPC user, please follow that procedure. Thank you. And just around Moodle, because I'm looking at what people are asking in the chat. If you had access to Moodle before, note that each course has a unique username. So please look for the login details for this course. You won't be able to use the login details for a previous course to access this one. Okay, and you should have been emailed. If you haven't, then I'll post an answer in the Slack channel.
Yes, just make sure just make sure everyone can join the Slack channel, because that is our primary method of communication.
Yes, yeah. If anybody has not received the invitation to the Slack channel or is having trouble, please contact Benjamin. Yeah. In fact, if you have any login issues, I think post it in the Slack channel, because when we close the Zoom session, we'll lose this chat. So please post it in Slack.
Yeah. So if you're having any issues, so everyone that has messaged now about Moodle issues, Eric, Toto, Isaac, Victor, everyone, you need to message in Slack. Put in any issues you're having, put it in Slack channel, and we will help you, because this is not meant for debugging little issues at the moment. So please message in Slack if you have issues, not in the chat, not in the Zoom chat.
Yeah, actually, if you go into the Moodle channel, you'll see that JJ has just explained exactly what to do. And so you should find that the username for Moodle for this course will start with S111 or D111. The S is for students, the D is for delegate if you're not a student. So it's either S111 and then 3 digits, or D111 and 3 other digits. Yeah. But I will put a question in, an answer in there and pin it into the Moodle channel on Slack, along with a screenshot so you know what to look for and where to go. Okay, thanks. I'm now seeing the questions popping up in Slack.
Kevin, do you want to
Okay,
start with
thanks.
the
Now that
demo?
we've got that out the way, I'll just give you a quick demo of connecting to the cluster and what you can actually see there. Let me just share my screen. Okay, can you all see a blank terminal window?
Yes.
Sorry, Benjamin, if you can just confirm that it's being
Yes, no, I
displayed.
can see it, yeah.
Ah, I think it's gone now. That
I don't see it anymore, Kevin. Can you share screen
okay.
again?
Yeah, let me just do that again. Okay, that's odd. Oh, I've got more than one open. Maybe I was sharing the wrong one. Let's just try. Okay, can everyone see the terminal? And it should now say, welcome to Lengao.
Yes, we all see it, that's
Okay.
fine.
Okay, good. Let me just exit from that and clear that. Okay. So that is the command I used to connect to our cluster. So I'm doing this from Linux. So in my Linux system, in my graphical user interface, I open up a terminal window, which allows me to type Linux commands directly into a Linux shell. The shell is also what's known as a CLI, or command line interface, or a text interface. So the command I type in here is just SSH for secure shell. Give my username, then @ and then the full server name, including the domain of the login node. So that's lengao.chpc.ac.za. So I press enter. Now you'll notice this doesn't prompt me for my password, and that's because we strongly recommend that you set up SSH keys so that you don't actually have to type in your password each time. That is explained in the notes. It's also explained on our wiki, as well. So you see that when you log in, the first thing I want to highlight, well, obviously you'll see a welcome message, but the first thing I want to highlight is the fact that even though you're connected to how, that is the public, the outside name for this computer. Its actual internal host name is login2. And that's because it's the second login node. Our entire cluster consists of what we call nodes. Each node is essentially an independent computer, which is connected over our fast internal network. And now the reason I'm highlighting that is that knowing which node you are on is actually crucial to understanding where you are on the cluster. So when you connect to the cluster using SSH, you should always be landing on one of the login nodes. When you actually run a computation, that's not going to run on a login node. You must actually launch that on a compute node. And compute nodes will all start with the latest CNODE for C node, short for compute node, followed by numbers which identify which compute node they're on. So that's very important to be aware. You can always type in hostname command, get the name of the server you're on or node you're on. In this case, login to. Okay. When you land, you use the pwd command, which is print working directory. You'll see that you will have landed in your home directory. Your home directory has the same name as your username, in my case, Kevin C. Right, and you'll see that its full location in the file system is under home. And the reason there's a slash at the beginning of that path is because it's an absolute path. So that's exactly where you are. If you want to see all the file systems that are connected, you can just type in df. Okay, you'll notice that it scrolls off the top of the screen because it's actually listing all these temporary file systems. These are essentially RAM disks. So don't worry about them. They're quite special. Instead, type df. And I'm going to type in a lot of Linux commands. I'm going to assume that you know the basics, though I'll explain some of them. So what I'm going to do is with the pipe operator in Linux, I'm going to take the output of the df command, which you previously saw was too long, and I'm going to filter it by putting that through the grep command, which does string matching on each line of the output that's fed into it. And I'm going to tell it, ignore all the lines that have temp fs. No, E, sorry, TMPFS. In other words, print a line as long as it doesn't have TMPFS. And there you'll see it'll actually list the actual file systems. So this is this output of the df command. There's the heading, the name of the file system, where it's mounted, the size in 1 kilobyte blocks, how much is used and how much is available, and then the percentage used, and where it's actually mounted. And that last column is the important information, because where it's mounted is how you, the user, access it. And you'll see that the home file system is actually called /home2, but it's mounted on /home, which is why when I type wd to see my home directory, it's on /home. So the mount point, as it's called, where the file system is mounted, is what you see as a user. The second file system that's important is the Lustre file system. And you can see here it's mounted on MNT Lustre. So I will go there, right? I can now type ls to list the contents of that file, that subdirectory. Right? And you'll see that the blue are all subdirectories, and users is where all the users are. So I'm going to go to users, and then I'm going to slash Kevin C. That is my Luster subdirectory. And you'll notice that I've set up the path so that it's displayed in my prompt. Okay, so I don't have to keep typing pwd. It will always show me in the prompt where I am. And that's where one keeps all the files, subdirectories, etc., that are used by running jobs. You don't ever write the output from a job to your home directory, because your home directory is on an NFS file system, which is serial. It's slow. Luster is a fast parallel file system, so you always want to use a subdirectory within your Luster directory for the input and output to your jobs. Now I'm just going to quickly go to example. Right. And here are some examples. And I'll just use the less command. These examples are ones that you'll be working on tomorrow. So don't worry about it. All this does is this will set up a job script to run a very simple Python program, which is going to be a parallel program using MPI, the message passing interface, to do its parallel computing. That's one of the approaches of doing parallel computing. And the Python 3.pbs is the job script file. I'll just add a very important point is that you should be consistent and use the convention of naming your job script files so that they end with .pbs, because we use the PBS Pro scheduler, which means that job script files will be specifically designed for PBS. So it's a good idea to, the same way you would end a Python file with .py. The other convention is people use .job, obviously job short for JavaScript, but I believe it's far more sensible to use PBS because it's specifically a PBS. Anyway, let's just have a look at that. And you'll see in this job script, these are the PBS specific instructions. So those are selecting the various arguments to the Q sub command and informing PBS that those are the parameters it should look at when configuring your job script. This one, -n, just gives the job a name. The -l is the way to request resources. In this case, I'm asking for 24 cores, and associated with the 24 cores, I want 24 MPI processors, and I want 2 of these. So effectively, I'm asking for 2 nodes, and since each node has got 24 CPUs in it, I'm asking for 2 full nodes. Then here's the other important one, is -P, that's the project, and I'm using the Winter School project. Now, those of you who already have accounts and are members of a research program will actually have your own project which you can use. If you don't have a CHPC account and you ask me to set you up with one, you will need to use the WCHPC, the Winter School project. Because I want 2 nodes, I need to use the normal queue. The normal queue allows one to use 2 to 10 nodes. So -q is for specifying that. And then last, but certainly not least, in fact, most importantly, I specified that this job must not run for more than 0 hours, 30 minutes, 0 seconds. So that's the maximum wall time. And you see the wall time is specified with a -l. -l is the argument to PBS's Q sub command, which specifies what resources you're requesting. So I'm requesting 2 nodes, 24 cores each, and I want those 2 nodes for 30 minutes. Then I set up some shell variables, my working directory. I now use the module command. This is something we'll be talking about tomorrow, which is how you set up the environment to access the software that's installed on the cluster. And then these are just standard shell commands, etc., where I'm just printing out messages. Modules loaded, and I'm using module lists to list them. I'm checking which Python interpreter I'm using, which MPI run I'm using. I'm confirming what my working directory in. All of this is diagnostic information that will appear in the output file of this job. There's a lot more there. Don't worry about this. You can go through this in some detail when we do tomorrow's practical, and you follow the tutorial sheet. And this is the command that actually runs the program in my job script. And that uses the MPI run command to execute nproc. That's the nproc will hold a number, which is the total number of MPI processes I've requested. So remember, I've requested 24 times 2, so there'll be 48 of them. So that says run 48 copies of Python distributed 1 per core across the 2 nodes, and that each of those copies of Python will run the hello mpi.py Python program. Okay, so that's a very quick introduction to the cluster, where you are in the cluster, moving around, and a job script. Okay, thanks. I'm going to stop sharing at that stage. And that's
Kevin,
to give you
we
an
got a
idea of
few.
exactly what each of these sessions will be like. It'll be a short lecture and demo of us showing you how to do a particular task on the cluster.
Kevin, can you hear me?
And yeah. No,
yes, we just
I
got
can.
a few questions in the Zoom chat. So the first one was, can we use Windows machine to access the
Yes, you
cluster?
can. Have a look at the video and the lecture notes on Moodle about that, about connecting.
And the next question was, they're not a CHPC registered user. So
Yeah.
do they need to register, or should they use that WCHPC project? What should they do?
Sorry, are they saying they are a user
They
already?
They are not a CHPC user.
Oh, if they're not a user, then yes, they must contact me and I'll set them up on the WCHPC project.
Yeah. Okay, cool. And I think a few people were able to resolve their Moodle login issues just by doing the forget password, putting the email address, and it seems some have received the username and password.
Yeah, if you put in your email address, but it only gets tricky if you have more than one Moodle user account, but it should list them. Yeah, contact me via Slack. I'm just answering that question. Just reading through that. I see somebody asked, my job script ends with .sh. Is that okay? Actually, that's the one case where we would say it's not okay. Because .sh means a general shell script or program. And very often you configure a job script, .pbs, for example, .job, to call a .sh file. And it's actually very helpful, especially for us when we try to help you, but also to yourself to keep track of which one is specifically a job script and which one is a more general shell script. So that's the one time where I would say, please don't use .sh as the extension for job scripts. There's also examples where you use a job script, a shell script file, .sh, to generate your job script. And it gets very confusing if you fill up your directory with a whole lot of .sh files and you don't know, and it's not easy to immediately spot which ones are the general shell script and which one are the specific job scripts. So I strongly recommend use .pbs. Yeah. You don't have to re-upload it. You can change the name on the cluster. And that's where I would recommend you go and have a look at a standard introduction to Linux and look for the MV command. The MV command in Linux will allow you to rename files or directories. Yeah.
I think Kevin, could you also just I'm just looking at a few Moodle issues. It seems most people have been able to resolve their problem just by following these steps. So I'm going to share my screen again.
Okay.
So in the Moodle channel, I just put these steps here. If you're having issues, first click on the link to forget your password, put in an email address. You should receive a username and password reset link, and then you should be able to access Moodle. Kevin, I think you also mentioned you should maybe use a username, but is it okay to put email address as well?
Yes, yeah, you can put in email address. Maybe I should just paste what I was going to copy in. Whoops. And the little picture of what you should see. So I've just, let me see if I can pin that. Maybe after I've posted it, I can pin it. Okay, so in the Moodle channel, okay, that's just reminding me that an hour has elapsed. Okay, so I just pinned the link to the password reset on Moodle along with a screenshot of what it looks like. So there are two options: search by username. If you know your username, like I said, that means you've received an email, but you find that their password's not working, or search by email address. So try the search by email address if you haven't received the email with your username. Otherwise, if that doesn't work, you can just message me directly and I'll give you your username and you can go do that. There we go. I've pinned that message. Yeah. Okay. Was there anything else, Benjamin?
I think covered everything.
Okay.
All right. So if there's nothing more, I'll conclude today's session. You will be receiving your next Zoom details for tomorrow. Just make sure you check the Slack channel that'll be posted there as well as on Moodle. So thank everyone for joining today, and we'll see you tomorrow. Please go through the content so far. There are a few lessons and videos you can go through in the meantime. So let me just show you what you can go through. Share my screen again.
And I'll just point out that we'll be available on Slack until for another 55 minutes to 4 o'clock answering questions.
So go through these slides, showing you the introduction part. So some of the content I covered already gives you an overview of CHPC and HPC. This slide shows you how to access the CHPC, and if you have any issues with that, and the notes on connecting to the CHPC as well. So there's content to go through already. So please do that before tomorrow. If you have any questions, let us know.
Right, thank you, everybody, and goodbye.
Thank you. Bye-bye, everyone.
Like I said, we'll be on Slack.